All right, I'd like to call this meeting of Senate Resources Committee to order. On today's agenda, we have presentation by Ocean Pasture Restoration, OPR. It's a very interesting topic. The first of our two presenters is Ted Crookston, who is a key member of Ocean Pasture Restoration.
First, let me be clear on some matters that are not reasons why we are here. We are not here asking you to solve our problem. We are not here asking you for money, and we are not asking you to conceive or craft complex legislation. Why are we here? We are here to extend to you, as stewards over the resources of Alaska, we want to extend to you an invitation. Here is exactly what we are asking. We are asking, we are hoping, we are urging that you will officially step forward and join in an alliance with us in commencing the great work of ocean pasture restoration right here in Alaska, to be the first in the nation to take the lead and step forward with us and set the standard for ocean stewardship. It is our hope and our desire that as a result of the time and experience we share together today, that you will become our advocates, our cheerleaders, true collaborators in alliance with us as we work to restore the ocean pastures of the Gulf of Alaska back to historical levels of health, vitality, productivity, and abundance of ocean life. Our vision is that Alaskans, friends of Alaska, vital industries, local communities, and good hardworking people from all walks of life may be blessed and have their lives enriched as a wonderful outcome of us doing the sacred work of restoring ocean life to vitality and abundance. Senators, I'd like to introduce to you now a dear friend and colleague, someone internationally recognized as a pioneer of sustainable ocean restoration work, someone who has dedicated more than 20 years to this field, and someone who, prior to that, had a long career in environmental management and sustainable development in a variety of official capacities. May I present our founder and president, the driving force and visionary of ocean pasture restoration, Mr. Russ George. I now, through the chair, pass the floor to Russ. Russ, would you please share your story with us?
My name is Russ George, and I'm very happy to be here, Chairman Reback and senators, to talk to you about ocean pasture restoration. It's a topic that I've been involved in for more than 20 years, and I'm very passionate about it. And as Ted said, you know, we're here to invite the Senate Resource Committee to take a lead role in participating with our work over the next number of years as we bring the oceans of Alaska back to their historic level of health and abundance. The first slide that is up is that familiar sockeye smiling at us from the waters of Alaska. And if Betty would go to the next slide, this is President Biden, who on the 27th of January issued an executive order to about the environment, especially about climate change and fisheries were unique, and he called for delivery of working solutions that to his office that would save fisheries and restore the climate. And he gave a deadline of 60 days. So that's before the end of this month that he wants to have solutions delivered to his office. But we think we have one of those solutions. And we're actually hoping that perhaps you folks might recommend it to him. He'd probably take a letter from you better than he would from us, right? And if we go to the next slide, this is the proof of what ocean pasture restoration does. I thought I'd lead with this. You probably all remember back in 2013, the fisheries forecast for the state of Alaska were that about 50 million pink salmon would be caught. And those forecasts are usually quite accurate. Well, that was for 2013. Well, instead of 2013 catching 50 million fish, they finally stopped fishing in Alaska after having caught 225 million, which is the largest catch in all of history. And the only reason the catch ended was because that all of the capacity ashore to receive any more pink salmon was filled. So they simply didn't have room to bring another fish ashore. So that was and our point, the arrow on that chart on the right, which was published by the Alaska Fish and Game just last June, I believe, shows points to the year 2012, and that's when we did our ocean pasture restoration in the Gulf of Alaska. And it brought back, you can see those 4 tall peaks on the right. The orange lines are the pink salmon. So in 2014, 1 year following our work, given that pink salmon have a 2-year life cycle, that's the largest run of pink salmon in all of history. And again, given that they're a 2-year life cycle, 2 years later, they got the second, you saw the second largest catch of pink salmon in all of history in Alaska. And so it just simply worked. And if you go to the next slide, Betty, we can, you're probably wondering what an ocean pasture is. Well, ocean pastures, we define them as large, slow-moving eddies. So this is a picture, a satellite map, I think you could call it, that I only took this one off the internet a few days ago. And this shows the Gulf of Alaska with these large circular eddies. I've outlined just a few of those. The one that we worked with in 2012 is called the Haida Eddy, because we were working with the Haida people from the village of Old Masset. That was the project started. But there's many eddies throughout the Gulf of Alaska. These days we're based, OPR Alaska is based on Kodiak Island in the town of Kodiak. So those are the eddies where we're quite certain the young salmon, when they leave the streams, they need to get offshore as soon as they can, because the shoreline waters are full of a lot of predators. And you can see that bright, streaky current that passes, that's sort of closer to shore than the eddies. That's a fast-moving river of water, and they don't want to be there, or they'll be having to take their Russian phrase books with them, because it'll sweep them right over to the western side of the Pacific. And if you go to the next slide, this next slide shows you that exactly how we do this. It's a fairly simple method. The work on the ship is not rocket science, but we do use a lot of satellite resources to monitor what we're doing. So this was our OPR ship in the Haida Eddy in the summer of 2012. We took a large fishing vessel, typical of one of the crab boats of Alaska, a 130-foot boat. When it's catching fish, it packs 200 tons of fish. We put it half full with 100 tons of mineral dust. Red mineral dust happens to be hematite iron ore, turns out to be the best product to use. It's a very natural product. It's what Mother Nature uses. And we sprinkled that across this one of these large eddies that's about 60 miles in diameter. And we just plowed the field. We drew a square across that eddy, and we went back and forth, trailing a stream of muddy red water behind the boat. And it's a tiny amount of dust. It amounts to just a few pounds per square mile. And the challenge we had was making it dilute enough to put it in the water. And the result of that is, on the right, that's an actual picture from the 2012 work. The clear blue water is what the water looks like before we treated it with the dust, which everybody thinks is a beautiful blue ocean is the healthiest one, but it's actually a lovely green ocean is what's really healthy, and what the fish need to live in. And if you go to the next slide, we can show you this is a slide of the natural effects of mineral dust that lands in the ocean. So the volcano there is the Aleutian Island volcano called Kasatochi. It offers us a natural experiment where the dust landing in the Gulf of Alaska also brought back the fish. So in 2008, Casatoche erupted in the summer months in mid-August. It spewed out ash for weeks on end. Probably 1 million tons of ash landed in the Gulf of Alaska. And when it did, it turned the Gulf of Alaska green. And nobody was actually looking at that at the time. We don't have satellite records that caught it. It was too cloudy. And there were no ships out there studying that part of the region, so we didn't see the plankton bloom. But what we did see is 2 years later, the sockeye salmon in British Columbia turned out to come home. They swam home to be the largest run of sockeye salmon in all of history in British Columbia. So we know that volcanoes do this, especially volcanoes in the Gulf of Alaska. The bottom picture is a picture of an iceberg that's cast off Greenland. And icebergs, because they've been collecting snow for centuries, all that snow that falls on the Greenland continent carries a little bit of dust with it, right? And the dust in the wind has been landing on that ice cap. And when an iceberg calves off of Greenland or off of Antarctica and drifts free into the ocean, it turns the ocean green around it. And that's because the natural dust in the iceberg is nurturing the ocean water. And up above on the right, that's a dust storm blowing out of Australia that blew from Australia to New Zealand a few years back. And when it did so, the dust landed in the Hobart Sea between Australia and New Zealand, promptly turned the Hobart Sea green. And the Hobart Sea the next year had the largest catches of fish in all of history. So this is a very natural process that Mother Nature does all the time. We don't claim that we're as good as Mother Nature, but we're smarter than her because we know that we can choose exactly when to put the dust and where to put the dust and the proper form, the most ideal form of the dust. So instead of using random forms of dust, we know that what the ocean's missing most is iron. So we just use basically iron ore, red hematite iron ore rock dust. Very natural product. And it works just fine. And if you go to the next slide, Betty, this is a picture of our actual work. So the boat down on the bottom is the British Columbia fishing vessel called Ocean Pearl. She's the largest fishing boat in British Columbia, 130 feet long. She packs 200 tons of black cod, typically, that she fishes out of the Gulf of Alaska when she goes out catching fish. I'm sure she's out there right now catching black cod. And we put 100 tons of dust on, 100 tons of dust on board. And you can see the picture up above. You can see the guys on deck there. Those are members of the village of Haida village of Old Masset that were the crew on the boat. And we're manhandling 50-pound bags of dust and putting them into a tank on the deck of the boat, mixing it with seawater, and putting it astern. The center picture on the bottom shows you can barely see a trickle of red, muddy water going there behind the boat. That's all we do, right? And except that once we've put the mud in the water, we have to study this with scientific gear. So the bulk of our work is doing top quality scientific work. So up on the top there's the guys are looking at a very fancy plankton net that's called in the ocean science world. It's called a Loch Ness, like the Loch Ness monster, because it's a $300,000 plankton net that has multiple nets that we tow behind the boat. It carries instrument packages on it to study the chemistry of the ocean, and we can fly it at different levels in the ocean and take samples and then bring it back up on deck. And it's one of the state-of-the-art science tools that we use. And the other state-of-the-art tools we use, there's a pair of yellow torpedo-like objects that are known as Slocum Gliders. Those are the state-of-the-art ocean robotics. They're an autonomous robotic oceanographic laboratory. They carry 15 instruments on board. They swim by themselves for up to 30 days, covering hundreds of miles. They dive down to every 2 hours they're on the surface, and the program tells them to dive, and they make a very slow gliding path down to about 1,000 feet down. And when they get to their prescribed depth underwater, at the deep, they fly back up to the top in a path, and every second they're collecting oceanographic science data. So what we do is an intensely scientific program to prove that it's safe and sustainable and effective. And if you go to the next slide, Betty, we've been doing this for quite a few years. So this slide here shows a 150-year-old Baltic schooner back in 2002, where I did the first experiment of this, and we sailed that ship from San Francisco to Hawaii. And on the way, we mixed a small quantity. We only put a few tons of dust in the ocean that time. We didn't have the capacity. It was our first test of this, and you can see me there with red arms because I'm mixing the dust in a barrel on deck, very manual, and you can see the red trail going out behind us, and we're actually under sail there, almost to Hawaii, 350 miles east of the Hawaiian Islands. And it was so successful, it was written up in the journal Nature in 2003. And if you go to the next slide, you'll see there's some more experience in this. The international community of ocean science has spent, since about the 1980s, they've been studying this, but since the early 1990s, they've been conducting experiments just like we did, where they take some iron-containing mineral dust out to the ocean and spread it around, but the international science community's experiments always did very small experiments, never more than 2 or 3 tons of dust. They've done 11 experiments at a cost of $300 million in public funds. They're very expensive because they tended to use ships like the ship there in that picture, which is the largest research ship in the world, the German ship Polar Star, has 2 restaurants on board. When I was on board the ship, when you go out to sea, you sit down at the dining table and a wine steward comes and delivers you and asks you what kind of wine you'd like with your meal, which is why that's how you spend $300 million doing the same kind of work that we could do by hand with our village project in 2012. And they always got results. The ocean always bloomed, but they never looked in places where the fish would come back, right? Or where they could measure it. It was pure academic work, and ours was purely about bringing the fish back. So the next slide, Betty, is it sort of lists the things that we do, right? So ocean pasture restoration, it certainly brings the fish back, but it has a whole bunch of miracles that it performs with the ocean. So, and bringing back the fish means that it's brought back all of ocean life, the plankton, the seabirds, the seals, the whales. In the 2012 project that we did, we saw hundreds of whales came to the plankton bloom to feed in the bloom when it was growing. We saw schools of albacore tuna come into the bloom when it was growing. The seabirds arrived by the tens of thousands in the bloom. Even though we were 300 miles offshore, there were wedges, V formations of Canada geese that had flown from shore 300 miles out to sea to come and feed in the plankton bloom. So it was a true oasis of life, right? But as the plankton is growing, it does that by taking carbon dioxide out of the air. It's just a plant, right? It's like a tree or it's like grass. It performs photosynthesis in the ocean, and it converts carbon dioxide into that new ocean life. And in doing so, it reduces ocean acidification. And in fact, it's the only means to effectively reduce ocean acidification is to, convert the CO2 that makes the ocean acidic into life instead of allowing it to become that deadly acid. But another thing that it does is it scrubs and removes mercury from the surface ocean. So everybody who fishes in the ocean knows that there's a problem with mercury that accumulates in fish. Well, the plankton naturally sticks to the mercury that's in the ocean. And a very large portion of the plankton that we grow sinks to the bottom of the ocean. And as it sinks, it literally scrubs the ocean clean of the mercury that's in the surface, which is where the ocean life is. So it's not sort of a perfect cure, but it will gradually cleanse the ocean of the mercury that arrives from the coal-burning plants. That's where mercury arrives. And of course, what it does, the other thing it does, people aren't quite certain about how the ocean controls the climate, but what we know is that plankton blooms, wherever they're blooming, they emit gases and things. They have a smell. So just like if you go into a forest, you can smell the forest. When you sail into a plankton bloom, you can smell the plankton blooming. And those chemicals in the air that you can smell are what cause clouds to form. And so ocean pasture restoration restores the plankton blooms, which will restore cloud cover and rain. And in fact, we were contacted by a group of utility companies in the western United States who have asked us to investigate doing this ocean pasture restoration for the purpose of improving rainfall in the western U.S. because these power companies, many of them are hydroelectric companies, and they said every drop of rain that falls, that fills their reservoirs, becomes power, for their customers. And so the answer is that this is really, we think ocean pasture restoration is the world's best hope to mitigate the lion's share of humanity's carbon dioxide that's in the air. And in the bargain, we get paid off in fish and healthy oceans and everything. So if you go to the next slide, Betty, we have a pretty simple business plan that we are hoping that the Senate Resource Committee can work with us on. And the plan is that we simply want to deploy this again. We want to do a 3-year commercial scale series of tests, restoring one large ocean eddy, the same as the Haida, similar to the Haida eddy, but south of Kodiak, every year for each of the 3 years. We want to study that intensively to prove the safety, the sustainability, and the utility. And we're quite certain that we will deliver hundreds of millions of additional fish into the nets and onto the plates of Alaskans and the rest of the world who are happy to eat Alaskan salmon, wild salmon, in fact. And of course, this will employ a few people in the company. We'll employ crews on our boats and scientists in our research labs and people in our business offices. But we'll grow a lot of fish that will employ thousands of Alaskans in the fishing industry. And one of the great values of this is that this is a qualified activity, mitigation activity under the Paris Agreement for climate change. So the Paris Agreement very expressly states that doing ecological restoration, especially nature-based ecological restoration in the ocean, where it removes carbon dioxide, where plant life fixes carbon dioxide into that plant life, just like a tree, a forest grabs carbon dioxide out of the air and it becomes the living forest. In the Paris Agreement, when you perform that task with ocean plants, you produce something called blue carbon, right? And blue carbon is a bankable, tradable commodity in the Paris Agreement, and we think there's a chance that will become one of Alaska's largest natural resources in the very near future. And so once we do this for 3 years running, to prove that this has commercial viability to our investors. We're an investor-based company, and we've proven to everybody's satisfaction that it's safe and that it's sustainable and that the fish are really coming back. And we will see the fish coming back the very next year, right? The binks 2 years after we restore a pasture, we'll see the reds come back. We're certain we'll see the chums and the kings come back. And we're certain we can target each of those species with particular pastures that they prefer. So our plan is, once we've done our 3-year project, we're not done. That's just the beginning. This is the beginning of a business and a lifestyle of becoming stewards of the ocean pasture. So just like humanity learned to take care of the pastures on land 10,000 years ago, we finally know how to take care of our pastures on the ocean. And we have to do it every year, right? From now until the rest of time, we think. So this will become a very stable business in Alaska, we're certain. And so if you go to the next slide, the final slide here. There's always questions that we get asked on this, and I thought we'd open this up for questions now, but here are some of the classic questions that we've been asked many, many times. You know, will it work for more than pinks, especially for kings and reds? We're absolutely certain it will, and we have data to prove it. How do we know it's safe? Well, in all of the history of ocean science, people have been studying natural dust events landing on the ocean. 150 years ago, Charles Darwin, when he was sailing around the world on the voyage of the Beagle, wrote in his journal that when he crossed through the Atlantic between Africa and South America, a massive African dust storm was laying down dust onto the deck of the ship, so thick that the crew had to shovel dust off the deck of the ship. And in all of the years of studying natural dust events, we've never seen a negative effect from these natural dust events taking place out in the deep ocean. And I guess I should mention this. We're only able to work in the deep ocean because the water close to shore has already, so the water right close to the Alaskan shore has perhaps 10,000 times more minerals in it than what we will achieve in the water that's in the offshore waters off of Alaska. So our water is very safe. And even if it were to come ashore, it couldn't possibly harm Alaskan waters, right? And we choose these eddies because we choose the location to put the pastures we choose are these long, slow-moving, long-lived eddies that are very readily tracked. We can call them up right now. At any hour of the day, we can, on the internet resources from the satellite services are now available, we can track our eddies. And so we know exactly where they're moving, and they simply don't come ashore. Right? So that's been the big question was, would we cause problems ashore? Right? And so we don't do that. I'd already mentioned ocean acidification. We think we're the cure for ocean acidification. Is it lawful and legal? Well, we've had a lot of flack in our work over the years for doing this from groups that have suggested that it's not lawful and it's not legal. Curiously, a few months ago, the U.S. National Academy of Sciences started holding a series of meetings on ocean carbon. And one of the meetings I was in, there were 50 people in the Zoom call that we were in, and one of them was the lawyers from the Columbia Law School who the National Academy of Science had assigned the job of reporting on the legality, the lawfulness and legality of this. And the woman from Columbia Law School said, well, in spite of the fact that people have said this maybe should be regulated under law, and there are green groups that say don't do anything because anything that humans do has to be bad, and it should be against the law. The fact of the matter is, it is not against the law. It's not. There's not been any legislation directed at this whatsoever. Right? It's not been judged necessary. So that sort of gives us an opportunity to talk with a group like the Alaska Senate Resource Committee. You know, this is it's a subject that lives in a legal vacuum, a legislative vacuum. And so we think the legal opinions are is that we have every right to do this, so long as we're only doing work in the ocean that's beneficial to the ocean, right? It's a perfectly lawful legal activity. And so we're hoping that, a group like yourself will say, well, you might as well take the lead on this, because nobody else has. Nobody in any state, nobody in the federal government has deigned to write any legislation or rules and regulations about this. And so those are the questions that we usually come up with. And so if you guys wanted to ask more, I'd be happy to take questions. And thank you very much for letting me speak to you.
Well, thank you, Russ, very much for the presentation. It sounds like you should take some of those naysayers out to Pasture and let us see for themselves. We do have questions. Senator Stevens.
Well, thank you. That was a fascinating discussion. I really appreciate learning more about this. You mentioned your investors. Who are your investors, and what are their returns? What are the returns?
Well, investors are entirely private investors. There's I'm not at liberty to identify them in the public, right, in a public meeting at the moment, but we're still working on, they have promised to provide us with the money, provided we can begin the project. And what we want to do with the project is enter into a working relationship with the state. So this is our first meeting with the state to begin that working relationship. So our investors said, you've got a milestone you've got to do. You've got to get the company up and running, and then you have to engage the state government, right? And so that today we've met our investors' milestone, that we are engaging the state and telling our story and answering your questions. Sorry, Senator Stevens, I've forgotten the second part of your question.
No, I was just asking who the investors were and what is their return? What are they getting out of this?
Well, their return is that this project will produce under the Paris Accord this blue carbon, right? So the Paris Accord provides that when anyone takes an effort to mitigate climate change, right, and the mitigation method is to either stop the emission of fossil fuel emissions, carbon dioxide, or to remove carbon dioxide from the atmosphere, right? So we're not stopping emissions, but we are removing carbon dioxide that's been put into the air by the burning of fossil fuel. And we receive what's called a carbon credit for that, right? And the carbon credit side of the business, blue carbon credits have yet to be sold. They've been provided for under the Paris Agreement, which only began trading in its carbon credit. That's the currency of the Paris Agreement, is carbon credits. The Paris Agreement's trading system only began January of last year. And to date, nobody has delivered blue carbon yet. So this is very much we're like an oil company. We know the oil is there. We've done the seismic surveys, but we have to do the development work, right, and bring it into production. So until we've done the ocean pasture restorations and made all the definitive measurements and met the requirements of the Paris Agreement for having accurate measurements that can be verified and certified. And in fact, the state of Alaska has the unique privilege to certify those credits, right? So that's our business plan, So we're ready to drill for anti-oil blue carbon, right? Which will relieve the carbon footprint of the oil that's produced, but we haven't done it yet. So that's our business model.
Thank you.
Senator Keel.
Thank you, Mr. Chairman. I guess a curiosity. You talked about mercury and the phytoplankton accumulating mercury, and talked about this removing mercury from the process. But the description of all all the biological activity and the salmon growth, I mean, mercury bioaccumulates. So is the mercury being in some way removed, or is it being sent to tables?
So what happens is mercury is it's arriving in the ocean almost entirely through the burning of coal from coal-fired power plants. And so it's an aerosol dust, right, or a vapor that lands in the ocean. So it's landing in the surface ocean. And so it's well known that we use on terrestrial eco-restoration or mine restoration or environmental protection programs, we do what's called biofiltering of wastes, where we pass polluted water through a wetland, a marsh, and the pollutants in that are captured by the organic molecules in the water, the bits of plant debris, and it sticks to it. Okay, so in the ocean, the same thing. When a plankton bloom is really abundant, the vast majority, it becomes food for fish. But the vast majority of that plankton of the plankton growth that is produced is an overabundance, and it sinks to the bottom. So as the mercury in the surface of the ocean sticks to this plankton particles that are on the way to the bottom sediments, in a very short period of time, in a matter of weeks, a plankton has a life cycle of only days at a time. So plankton's blooming and reproducing over and over and over every few days. And the vast majority of those plankton plant life, little microscopic plants, are sinking to the bottom. And as they sink, they take the mercury with them. So it's...
Thank you. I appreciate that answer. So the other thing, I was interested in your presentation, your chart that shows the correlation between your fertilizer and the pink runs, suggested a lasting effect, if that's a causative effect. But you said in your presentation, I think, that you had to do this every single year. I mean, nothing lasts forever but the earth and sky. What's the lasting effect, though, if we're to take your chart as proof?
If you could switch back to slide 3, Betty, I can point out a little bit on that. Well, for the orange bars on that are the pinks, right? And the green bars, for instance, are the chums. So you can see the size of the bars. The chums are a bit larger as well, right? But yeah, it's a bit of an inconsistency to say, because we see the pinks come back. When you have a lot of pinks come back, for instance, in 2013, when the pinks were coming back, I received letters from, because I was working with Native people in British Columbia, I received letters from many, many, many village councils who were reporting that they'd never seen so many fish in their local streams. They said, one village chief wrote me and he said we had little tiny streams no more than a foot wide that flow through the village that were so full of pink salmon spawning in these 1 foot wide streams a few feet from the ocean. He said they'd never seen anything like it. So in fact, there was a terrific spawning success. So the reason why we see those repeated high numbers is that there was a fantastic success of spawning in the pinks. But we do want to feed the fish. So the boat that we use, the Ocean Pearl, which is a black cod boat, we chartered it for the summer in 2012. Well, in the winter months, she's out in the Gulf of Alaska black cod fishing, right? And the captain of the boat reported to me that when he was catching black cod that winter, 6 months after we put the dust in the water, that his catch was a far superior quality catch than he had prior caught, right? So the fish were fatter and it weighed more and a higher concentration of fat, so they were a much superior quality of fish. And in fact, we saw that when the tuna came into the bloom. We had a vast school of albacore tuna come into our plankton bloom in the Gulf of Alaska, which is not a place where albacore tuna are commonly found. They've been known occasionally to come into those waters, but it's generally too cold for them. But we had thousands. We had the classic pictures that you see of schools of tuna at sea, where the water was white as far as you could see, with tuna splashing on the surface. We started catching those albacore tuna and studying them, and the captain of the boat for the research trip was a guy who was in his 70s, and he'd spent 50 years catching fish on the British Columbia coast. And he'd done a lot of tuna fishing, and he said in all his life he'd never seen anything like it in terms of the tuna, because we caught the tuna, the albacore tuna. He said they were terribly lean, they had no body fat whatsoever. He was saying, well, they're tuna and there's a lot of them, but they're the lowest utility grade fish possible. He said they were almost worthless. He says he wasn't even sure he'd bother to fish for them if he was out on a tuna trip. But within a few weeks, the tuna fattened up, and so we saw the tuna put on 1% of their body weight per day. And within a couple of weeks, the tuna had turned from utility grade to sashimi grade tuna, which is the highest value tuna in the ocean. So we know that they don't stay that fat. When the bloom lasted about 6 months, according to our records, and then it was gone. So the food was gone. So what we have to do is, like any pasture, a pasture on land. If you want to have a good herd of livestock that uses that pasture, you've got to take care of that pasture every year. Right? So that's pretty much the answer.
Thank you, Mr. Chairman.
Question?
Thank you.
Well, thank you, Russ. To be clear here, and for the members of the committee and their consideration, this all sounds almost too good to be true, most of it. You said that you're not looking for money. What is it that you're looking for specifically from this committee?
Well, what we hope to enter into some form of public-private partnership with the state of Alaska, right? Where we need oversight. The core of the Paris Agreement is that projects have to be transparent, and that the stakeholders have to all be informed. So we're achieving one of the principal milestones of the Paris Agreement by meeting with you folks today, because this begins our transparency. We're ready to tell you almost everything that we can. Yeah. We keep a few business details in private when we're in public forums, but in private we're happy to reveal much more. And so we're hoping that the state of Alaska will simply say this is a good idea and it should be tried. Right? We really don't need anything more than that. We need you as our friends and allies on this project. And if the state of Alaska says it sure looks like it worked once, it's worked many times with volcanoes. There's 3 spectacular historic events where Aleutian volcanoes erupted, and the dust landed in the Gulf of Alaska in the summer months, and the fish records show that the largest runs in history of fish came back. But they're few and far between. So there's Casatoche in 2008. There's another volcano in the 1950s, and another one in the 19-teens, like 1918. So volcanoes, you can't rely on them, right? They don't dust the ocean often enough or necessarily at the right time of the year, right, to get the effect. So we're smarter than a volcano. We're not as big, but we can put a small amount of exactly the right material in exactly the right place at the right time to support the young fish. We all know we send lots of smolts, lots of young salmon out to sea, and there are documentary films. There's a fantastic film on the Atlantic salmon called Atlantic Salmon Lost at Sea. And they've decided, the Atlantic Salmon Federation put it together. They said, the problem with the Atlantic salmon isn't that we don't send enough smolts out to sea, but they just aren't coming back. And then the answer to that is that they're mostly starving to death out at sea. And what we do is we provide food for them, especially when they arrive, right? If we hit them, I call the pastures nursery pastures. You know, we try to target the pastures that feed where the baby fish are most dependent. And if we can get them a good start in life, then they will thrive, and they'll come back in vast numbers. So,
Well, thank you for that clarification, Senator Machicki. Okay.
Here, I'll throw it out.
Yeah.
Actually, yeah, Russ, I'm curious. So we grow a fraction of the quantities of pink salmon that are grown from hatcheries out of Russia and Japan. Just curious if they're considering employing this technology to increase the yield of those fish. I mean, obviously they must have the same challenges.
they do, and we know for a fact that they're considering the very same technology, right? You know, we've been in touch. I've had leaders from countries all over the world contact me, and I've spent the last number of years, since 2012, I haven't been, I wish I'd have been out at sea, but I've been flying around the world over and over again to meet with leaders in various nations around the world, especially island nations who are desperate to see the fish come back. So we know that the Russian salmon people are confident that this will work. They haven't yet made the decision to do it, but we don't think it's far off, right?
Do you have plans to go out this summer and conduct or anytime soon, or what's the forecast?
Well, we would sure like to go out this summer. That was our plan when we started working on this more than a year ago, to get OPR Alaska up and running. Can we get out this summer? If we could make some really quick time progress with the state and exchange some letters, right, with the state, so that we have the state's blessing to do this, then it's a close call. It's a bit late for this summer, but we might make it, right? It takes us a bit of time to prepare and to gear up. So the HIDA project took place in mid-July. And the Casatochi volcano erupted, I think, on August 10th. Well, I typically say July, the end of July is our sort of drop dead date. If we can't get the dust in the water before the end of July, it's not ideal. We'd like to get it in the water earlier than that, much earlier than that. Right? So if we did, then we could, then Alaska could expect to see a couple of 100 million extra fish next year.
Yes, Senator von Imhoff.
Thank you. This was a fascinating presentation. One of your first slides is to talk about President Biden's executive order. If it is definitely a goal of the Biden administration to affect climate change and to, I think, as a byproduct, then restore the fisheries. Do you believe that there's government financial support, federal government financial support for this, and momentum, as in, if we're going to start reading about this in mainstream media like CNN and NBC?
I bet you reminded me, I should say, through the chair, let me answer that question. I think the federal government is committed to spending, vast sums of money on projects that are like this. We are really a private venture capital for-profit firm, so we're not looking for state or federal funds. We have lots of investors who think this is a fabulous idea, and if we can, meet our milestones of engaging the proper government agencies, so that we ask them not for And there is no permit structure, right? So there's no permit in either state or any state or federal government agency that we can apply for, right? No, but there is no legislation that has said you need this permit to do this work or need to go through this review process. So we're not looking to enter that. This is classic sort of beneficial research, but it has a commercial side effect, right? So, I mean, the best outcome for us is if your group were to write Senator Biden and say, wow, there's this interesting idea, ocean pasture restoration, that meets your executive decree, right? What if it did, right? It'll bring the fish back and help you meet your climate change commitments in one project. Then I think we'd be talking. We'd have a lot of interest from the federal government, and they'd probably chip in lots of resources. So the HIDA project in Canada, when I set that up, the Canadian Space Agency loved the project so much, they put on a 3-day seminar for my team. They gave us the passwords for the International Ocean Observing Satellite Fleet, so that when satellites were going over our project, the HIDA Eddy, we could call up the satellite before it got there and say, make sure these instruments are turned on because we want this data from that satellite. We called up NOAA. We asked them if we could buy a satellite buoy, drifter buoy from them called an Argus buoy that you throw over the boat, over the side, and it has sea anchors, so it's stuck in the eddy and it drifts with the currents. They loved the project so much they said, well, do you just want one, or can't you take more? And I said, well, I'm not sure we can afford more. And they said, no charge. And I said, well, sure, I'll take more. And they said, well, they come on a pallet of 10. And I said, okay, send me a pallet. And then they said, will you take 2 pallets? Right? I said, well, I don't know, how much is this? How am I going to get it to my ship in time to get it on board, to get it out to sea? They said, no problem. We guarantee you tell us where the ship is at, whatever dock, any place in the world you're at, we will deliver the 2 pallets of these satellite-monitored drifter buoys that talk to the satellite every 2 minutes. The drifter is taking measurements of the ocean water, and every 2 minutes it's talking to a satellite, and it transmits the data back to us. So NOAA was completely engaged. The National Research Council of Canada said to us, well, we love this project. If you'll hire young scientists to work on it and young people to work on this, and defined as young as anybody under the age of 35, the National Research Council of Canada said, we'll pay 50% of all costs of those people for the company. So they paid 50% of their salary, 50% of their benefits, the whole works. But those were sort of existing programs that we didn't need, but they were sure beneficial. And what happened is it engaged those groups with us, right? The Export Development Corporation of Canada signed an agreement with us. We worked with them for 2 years. They loved the blue carbon idea so much that they said, well, the Export Development Corporation of Canada is issuing you a product guarantee for the export of your blue carbon. So if you produce blue carbon and you want to sell it to a foreign country, for instance, the United States, the Canadian Export Development Corporation wrote us a product guarantee worth 85% of the face value of the carbon, so that we could, when we talk to customers, we could say to the customer, look, at this product has been not only verified by the Canadian Export Development Corporation, it's insured, right, to 85% of the value. So we expect to have lots of groups in the U.S., in government and research agencies and things like that, that will want to help. And that's sort of our business plan, is to not go hat in hand into them and say, we desperately need your money, but we're certainly going to have an open hand. If, we're going to inform them what we're doing, and we're going to say, if you want to participate, that's great. So,
All right, well, thank you. We have a couple more questions, I think, and I'd like to wrap this up by 4:40, so that gives us just a few more minutes here. Senator von Imhoff.
Thank
Okay.
you. So you mentioned that at this point, no permit is required either from the state or the feds really to do this work, not even from the Department of Environmental Conservation. So essentially, you can deposit mineral-rich iron dust in the ocean with no permit, no permission from either the feds or the state. Then two questions that I have for you is, what is stopping me from going out in my little boat and dumping whatever I want in the ocean? And second of all, what is it you need from this committee, and why do you need it if basically nothing's going to stop you?
Well, we're not saying nothing's going to stop us, because we know that somebody is going to write legislation around this work, right? And so what we want to do is carry on a really carefully planned and executed 3-year pilot project, commercial scale pilot project, where we gather intensive data and prove that it's safe and sustainable. And we think from that, legislation will be written that will define this work, right? Because we put such a, the reason why this is not like you can dump anything. So putting, rock dust in the ocean in the tiny amounts that we put in, right? We put 100 tons across an area 100 kilometers by 100 kilometers. That was, so 10,000 square kilometers. It's a vast area of ocean. The dilution, what we tried to do is, we know that the water there had only 3 parts per trillion iron before we went there. And we tried to raise the concentration to a part per billion, right? We know the water along the shore of Alaska, right? A mile off Kodiak Island, the concentration of iron in that water is parts per million. So it's at least 10,000 times higher concentration of the same mineral substance than what we put in the water far offshore. So number one, we can't put this in close shoreline water. We have to be in the deep water. We have to be beyond the continental shelf, where the water is very deep, where these large eddies form, and where the ocean is starving for minerals because the water's so deep. Right? So that's it's a complex issue, but your questions are exactly spot on. How do you begin when you're the pioneer in something like this, right? And government agencies haven't decided how to regulate it, or if they ever should, right?
Thank you, Senator Keel.
Thank you, Mr. Chairman. I guess a question of scale. I mean, I don't know if, I know your 100 million ton experiment was just an experiment. I appreciate that.
100 tons, not 100 million. 100 tons, yeah.
Fair enough. I looked at Casatochi, the volcano, though, and I assume that we're talking about, an island blew up. We're probably talking about more than 100 million tons.
Millions of tons, yeah, exactly.
So, and the reason I ask is that while August wasn't perfect for fish feeding, it was pretty good for algae growth. But I think the estimate was that the additional algae and plant life that bloomed there grew about 1/6500th of the amount of carbon, or attracted 1/6500th the amount of carbon that the burning of fossil fuels puts in the air each year. So I'm curious about the scale to which you think we need to apply this for it to be a meaningful carbon solution to submit to the White House.
Well, when the largest experiment that was ever done was done off that prior, other than our work from the academic world, was done off that icebreaker, the German Polar Star that I had in one of the slides, right? They put in, I think, 4 tons of iron into the Southern Ocean, about 500 miles south of South Africa. The chief scientist in that group said to me, I sat down with him, and I said, well, what do you think, what was the amount of carbon fixed out of the atmosphere based on the iron that you put in? And he says, oh, well, it was a ratio of 1 to 1 million. So each ton of iron captures 1 million tons of carbon dioxide. Right. So that's the best scientific data on this, right, from the people who have actually done the work. Now it's an academic debate because it's never been put into a process where we've been doing it at this kind of scale, right? But we know that the ocean life, the reason why the plankton bloom, the iron, a little bit of iron goes a long way, is that the zooplankton recycle the iron. So the plankton, the plant plankton, the phytoplankton grows at the surface, but the zooplankton, the little shrimps and copepods, krill and things like that live in the deep water, come up every night to graze on it, and they consume it, but they save, and then they go down in the night, before dawn. They go back down to the deep in the dark, and like a cow sitting in a pasture chewing its cud. They chew its cud. They chew their cud during the daylight hours, and defecate the plant waste out like a cow pie that sinks, and they swim back up the next night to the surface to graze again. Well, they scavenge the iron out of what they eat. They take the iron back to the surface, right? That they've scavenged out of the crop. So it's a very dynamic biological recycling system that makes it work. And of course, that's part of the purpose, right? That's the purpose of our project, is to actually do the measurements, right? Nobody has actually done this. So we want to do the measurements 3 years running and get the data and let the data speak to us and tell us what the realities of this are, right? And we're sure we can do that in 3 years' time.
Thank you. Boy, if I had to guess, I'd say Senator Keel has another question.
Oh, no, Mr. Chairman, I'll be eager to see what the data looks like when it's produced.
Yeah, thank you. And we have one last question from Senator von Imhoff.
No, I don't.
No. Okay, well, we really appreciate you taking your time, Russ, to come before the committee today, and thank you for your interest in all these things and in making our oceans a better place and increasing fish populations. We'll mull this over and we'll talk to you here in the future again. Thank you again for your presentation. We appreciate it.
All right. Well, thank you so much, all Chairman Reback and the rest of you. It's just been great to have the opportunity to. It's a real story of hope. This is science at its best. It's just fun, and it's going to be productive, and at the very least it's going to keep Alaska's fish stocked to the fed up to the gills, right?
Well, thank you.
Into the future. Right?
Thank you again.
Oh, no, Mr. Chairman, I'll be eager to see what the data looks like when it's produced.